Okay, welcome back. So in our last video, we applied loads to this structure. We applied load combinations too. Now let us try to analyze the building and see if it's stable. If it is failed, we will know. If it's stable enough, we will know. If there are any errors, we will know. So our next stage now is to first let us see one more time the 3D render. So this is how our building will look like. So let us now close this. So let us go to analysis and print. Now here we're going to perform analysis and we're going to include all of these in our report. We add, then close. When we do that, we're going to go to analyze, run analysis, save, and then we wait for the analysis. And as you can see, our building, if we check here, our building has got 0 errors and 0 warnings. This means that our building was rightfully designed. Our building was designed correctly. The loads were applied in the correct manner. So we're going to view the output first and see what we have. So this is the output. Let's go to the results. As you can see, loads applied. Here we can check them. Maximum displacements in radians and or centimeters. Reaction loads, all sorts of things. So this will just show us that our building has got, our model has got 0 errors and 0 warnings. Let us now design this building. Design by Rcc Design is now determining how many reinforcement bars we'll put in each column or each beam, how much volume of concrete we're going to use, all sorts of things. Let us go to design. So when we design now, go to concrete design. We can come here. Obviously, there are 3 options here: select parameters, define parameters, and commands. So when we go to select parameters, we take them back here first. We're going to see the things that we can choose to tell our software Staad from. For example, if we choose compressive strength of concrete, we can tell it that let us use, let's say, M20, M25. We can tell it that. We can also assign Staad Pro to use yield strength of main reinforcement such as FE415 MPa, and shear reinforcement too. We can choose FE415. So these are options that we can use. We can choose the clear distance or the clear cover, the depth of cross section, the E-face, the type of bracing. So we can have types of braces too if we are doing columns, such as 2 columns. And then let's just cancel this one. Let's close it. After we select those parameters, we can define them now. We can define them. But then in this case, what we're going to do is that we're just going to tell Staad Pro to use whatever it will see fit using our model. So what we're going to do is that we're going to tell it to design beams, columns, and tell us how much concrete is needed based on our calculations, based on our load parameters. So we're going to come here to press commands. This pop-up window has appeared. So we're going to tell it to design the beam. So we add. As you can see, it's come here with a question mark. This question mark means that the parameter hasn't been assigned to anything yet. So we are still going to assign this command to the beams in our model. And then we are going to select design column option. We're going to add 2. And then since we're not designing the slab, we've already applied slab load in form of floor loads. So we're going to, so we didn't model any element or plate here. So we're going to skip this, and then we're going to do takeoff. So takeoff, as you can see, takeoff means that we tell Start Pro to print the total volume of concrete and weight of steel reinforcement for the beams, columns, and elements designed. So we're going to add these two, and I'm going to close it. As you can see, we're going to assign the beams. So we select design beam. As we did earlier, we're going to select beams parallel to x-axis and beams parallel to z-axis. These are all beams. Then check this option, assign to selected beams, then assign yes. So as you can see, the question mark has disappeared and a mark has appeared. So this is a symbol that this parameter or this command has been assigned to the beams in this particular building. Now we're going to go to the design column option. We're going to select beams. Let's save this. So let's go over here, design column, select beams parallel to y-axis. I'm going to select and assign to selected beams, assign yes. So now we've put in parameters. We've told Staad Pro to design the beam, the column, the concrete using ISO 56. As you can see, the code is ISO 56. ISO 56 is a design code for RCC, reinforced concrete and plain concrete in India. So now I'm going to analysis and print all, and close, and then analyze for analysis, save. So our building has appeared, 0 errors, 0 warnings, 1 note. So view output now, done. So as you can see, let's go to results. This is a note. This note tells about one-way loads or two-way loads, and concrete represents volume of, it's just a note, concrete quantity represents volume of concrete in beams, columns, and plates designed above. Okay, so we can see that our total concrete quantity needed for our particular design or particular model is 19 cubic meters. And then the bar diameter for reinforcement is 8, 10, 12, 16, 20. And the weight in newtons is 5,888 newtons for 8 millimeter bar diameter, 8 meter diameter bars, and the others too. Let's check our results now. So as you can see, we can check total applied loads. We can see the loads applied for maybe each joint and the stiffness quantities and the supports, reaction, everything. So let's go to concrete design now. So this is where our Rcc design is. So let's check for beam number 1, design results. So length of the beam is this much, 5050 millimeter, size is 230 by 300, cover is 25. So Staad Pro saw it fit to assign a cover of 25 millimeters. We did not assign the cover, we just told it to design the beam, column, and then it used our dimensions, our load applied, to see which cover would be suitable for our model. So it saw it fit to assign the cover, the clear cover of 25 millimeters. And then let's now go to summary of reinforced area. This is in square millimeters. So top reinforcement, we're going to see that the beam is cut into 1, 2, 3, 4, 5 sections. So each section, we're going to see how Staad Pro has assigned the top reinforcement. So here it's 0, 0, 0, 0. And then the top reinforcement here is 667.49 square millimeters. Same here. Bottom reinforcement is this one and this one and this one. So how are we going to read this? We're going to get the maximum reinforcement. So top reinforcement, our maximum is 67.49 millimeters squared. And the bottom reinforcement, our maximum is 313.44 millimeters squared. This is our reinforcement area. Now, provided reinforcement. is, so the top reinforcement will get the maximum here, 67.49 square millimeters, and do it here. So as you can see, the Staad Pro has provided and say that we should provide 6 bars of steel reinforcement, each having 12 millimeters diameter. And the bottom reinforcement for the top one is this one. So this one here. So 4 bars of steel reinforcement, each having 10 millimeter diameter. And then for shear reinforcement, we're going to get the maximum too. So we can find that the maximum is, so here in IS code, it's mostly recommended to use 2-legged stirrups. So these are stirrups. So we're going to get the maximum, is always the same. So we're going to get maximum here, 2-legged stirrups, which are having 8 millimeter diameters, placed at center to center distance of 200 millimeters, as you can see, this one. So this is for the beam. Beam 2, the same, we can read it as usual. Let's try to see column design. Column design. Let's find, as you can see here, we've typed column. Okay, so column number 18. So design. So length of the column is 2,750 millimeters. Cross section is this much. The cover is 40 millimeters. So here we are going to, so this is the design. Required steel area is 189.49 square millimeters. Required concrete area is 23,686.39 square millimeters. Main reinforcement, we are going to provide 4 bars, each having 12 millimeter diameters. And this is equally distributed. So if we use the curves, the interaction curves, we know what we're talking about. We can distribute them equally. Let's say on all four sides of the column, since this is a square column, or we can distribute them only on 2 sides. And then for tie reinforcements, we're going to provide 8 millimeter diameter, which are rectangular ties at a center to center distance of 190 millimeters. Now, section capacity based on reinforcement required, including tons per meter. These are all in IS 456 and the interaction curves in SP 31. So we can find these things in SP 31 and IS 456. PUZ, these are all moments. So everything has been designed for you. The same area here, start space, we're going to see column number. So every column, every beam has been designed. So we've seen how this works. Let us now go to post-processing mode. Okay. So when we come here, we're going to see that here we've got the rotation of each beam. Let's go to the beam first. As you can see, these are forces. If you zoom in, these are shear forces, or shear force and shear force diagrams. So if you want to enlarge the shear force diagrams, you can press Ctrl and then move your cursor upward and downward. So if we're going to do this, we're going to enlarge it. We can reduce it too. So these are the forces. The stresses are these. If you want to check them, so these are the stresses. The graphs. So if you press this beam, the shear force and bending moment diagrams are here. You can check them out. You can read this too. Let's go to beams again. Animation. We can see the deflection of our model. So have you seen? It's just that's too small to see, but we can see deflection too. Let's go to the beam again. So we can see the forces applied according to each combination of load. If we go to forces here, let's go to this point. You see, this beam has got this force, Fx, this one, Fy, Fz, this is moment, and moment. Stresses. As you can see, this beam has got this kind of stress. So if you check out this one, as we move, given the distance, let's add display later, display what? So as we move, if you see on our top right corner here, this is a section of the beam, and these values, the corner stresses keep on changing as we move along the cross section of the beam. So we can find everything here. Let's go to beam once again. Let's go to processing mode. Reactions. When you press reactions, this is what comes. So all the reactions at the supports have been displayed. If I want to change and to check out, we can do it in this manner. We can see. Let's go to these two displacements too. All these displacements according to each combination of load and the beam or column have been put. Check here, all these negative 1.169 millimeters in the y direction. Everything has been done for us. Displacements to reactions, beams, you can check the bending moment diagram, and then we can also let us try to say let's do this. So beam, let us pray. As you can see, these ones will show us the shear force, the bending moment, the torsion, bending moment in the y direction, in the z direction. Let us press this one. So see the shear force in the x direction, and then let us try to minimize it. So in this direction, this is how it will look like. This is how it will look like in a symmetric view. So in the y direction, this is how it will look like. Shear force in z direction, it's the same thing. Let us remove this. Let us go to moment in the z direction, moment in the y direction. This is how it will look like. As you can see, we can maximize it to see it properly. We can minimize it. This is the y in x direction. This is how it will look like. We can maximize it too, and see. We can take a look at it from a different type of view. You can see it here, or this point. You can see it here. It's better to use the isometric view and see it properly. So this is how we're going to look at it. Let's remove this. Let's remove this. So the y direction. This is our bending moment. This is our forces. Let's look at it in this direction. So this is our bending moment per each beam. That's how it's going to look like. So as we can see, this is how we model and design a building. This is how we model and design a building using Staad Pro. So we've learned how to draw geometrically, how to assign loads, how to assign load combinations, and we've also learned how to run analysis of a building and how to design the building. As we can see, our model has got 0 errors and 0 warnings. This means that our design building was modeled correctly. So this is how we design a building, and we've come to a close to our session. My name is LUKAMA. Thank you very much.